So I would like to ask all of you to take a moment, look at this image, and tell me, do you guys think your fingerprint is important to you? Can you raise your hand if you think you do? See, I feel like some of you are not that really knowledgeable about your fingerprint and what it can do. So to you, it's really just something you can't remove off of your body, right? But imagine if you saw your fingerprint like this, for all of the whorls and all of the little indents that you can see on your finger. Imagine how much color you can give to your life just by looking down at your hand and thinking, wow, there's really something to it, rather than just a hand. I want you to take a look at this image that I will come back to later and think of one word. Write that down, put it in your phones, just think about it, remember it. Next, I want you to look at these 3 images. Find something that connects them and think of that word. Imagine now taking that colorful fingerprint, no longer black and white and just grayscale, and now making it 3D. That's what biometrics allows us to do. See, biometrics is a system that takes your physiological and behavioral features and turns that into authentication technology. So your touch IDs on your iPhone, your iris scanners on your Samsungs, all of that is biometrics. See, Apple came up with the fingerprint sensor back in 2013 on the iPhone 5S. And right now, we're at the iPhone X, and we still use this technology. Why? It's because it's secure. We believe that it's secure. And what it does is it allows us to open our devices, authenticate it with ourselves. No one can truly replicate us. And the only problem with this is, as you guys have probably seen in movies like the Agents of S.H.I.E.L.D., sometimes people like to lift your fingerprints off of glasses and then try to unlock your phones with them, right? And so people still have this stigma around this technology. And see, Apple's design is pretty simple. Unlike the old competitors that usually use optical lenses to look at your fingerprints and take pictures of them, Apple has a 4-part system which actually uses a conductivity sensor. So your finger has a dermis and a subdermal layer. That subdermal layer conducts electricity, whereas your dermis layer doesn't do that. And so what it looks at is the difference between the 2 layers and uses that to identify you. And so the first top part, the little circle, is actually a laser-cut sapphire crystal. And its purpose is to make sure that everything inside stays protected, and it's also easier as a lens to see through. There is then the stainless steel ring, and that ring's purpose is to detect when your finger is placed on. And that's really its only purpose. And then that really super complicated kind of rainbow-looking thing, that's actually the conductivity sensor. And what it does is when you press your finger on it, it actually senses that your finger is there. It takes your finger, takes a picture of it, and then converts it into a hash code. And that hash code is now a new template that is used to recognize you. The really cool thing about this technology, though, is that it doesn't actually save the image of your finger. So it's not like someone can take your fingerprint and then hack you like that. What the technology does is it runs through this template that is now just numbers with an A7 sensor from Apple. And from that, it looks back at the past template and then uses that to verify you. So it's not like it's actually storing any information, which is actually something that many people believe. This is how complicated your finger really is. At the beginning, I asked you to look at your finger, and to many people, it was just a finger. It's just a fingerprint with swirls that identifies you at airports sometimes. But really, look at all these different parts of your finger. There are ridges. There are the bifurcation parts. They even look at all the grooves in your fingers to see which parts lift up more than others, which parts do you press down more on. And then came the Samsung S8. With the iris and face recognition in 2017, right? And what the face recognition does is actually, if you guys ever have been on Snapchat, it takes 80 nodal points of your face, and it looks at your eye distance, eye grooves, how deep your eye sockets are into your face, different things like your nose length. And so it takes all these different nodal points and uses it to verify your face. Here, we already have 2 different biometric systems, which are highly different, but uses you. You are the person who allows all of this to happen. We then have the iris sensor. And this is actually really cool because with multibiometrics, visual wavelength sensor is revolutionizing technology. Here we have a near-infrared receptor, and what it does is it doesn't take the color from your eyes, but it takes the 700 to 900 nanometers of wavelengths, which is, I can't even tell you how big it is because it's just that small. And it looks at all these complicated structures in your eyes, and it highlights them, so it almost looks like the moon's surface. It's like little craters, and it uses that to identify you because everyone has a unique pattern. But see, with visual wavelengths now, you can now see the different color segments of your eye. And by doing that, now there's 10 times more security and infinitely more possibilities that you are able to do with the color from your eyes. The only thing is that the structures aren't as prominent, which is what people are still trying to work on. And see, from all of those three examples, now you can see a pretty clear outline of what it does. First, it captures your sample, and then it extracts it. And it extracts all the different codes to make it into some sort of hash code or some sort of different template for you to use later on. And then it compares that template with one that you've already stored later when you try to access it again. And then that match is later gone through with what you've already stored and then taken for your device verification or authentication. And imagine the possibilities of how you can use this technology. You have airports where they're already trying to use it. Banking and finance, how many people here have paid for something with Apple Pay? You have blockchain where you can now authenticate keys. Healthcare, law enforcement, and mobile sectors. Just this morning, I woke up and thought, what if we could use X-rays to go through aging so that biometrics are more secure? Because then you could use what the X-rays see from you and update it with the error recognition. But then again, as I said, what if someone lifts your fingerprint off a glass, right? What if someone were to take your phone and then scan it across a large database? There was actually a fraud case where people believed that the government was storing all of their fingerprints so that they could use it in case they ever need to get into your phone. And that's really scary, thinking that people can actually take things that are on your body and replicate them, right? And there are molds being made. And so what I thought was, is there a way to fix this? Is there a way to overcome this problem? And I went to Arduino, and I went to MATLAB, and I thought, what could I do? How could I get a better understanding of biometrics so that I can educate other people on how it works? And so I actually purchased a fingerprint sensor, which allowed me to see how fingerprint sensors actually work. So here, we have a test program for fingerprint sensors. What I have done is made an enroll key already that allows me to upload different ID fingerprints. So I can upload my thumb, my middle finger, my index finger, any finger I want, so that I can look at how they actually look at confidence intervals. And so here, if I press my fingerprint on this sensor, it tells me the confidence at which my fingerprint is read at. And it's pretty interesting because if I go through to a different fingerprint, now it's fingerprint 2. But that confidence interval has gone down. And you can see the more I press on it, usually the better it is at detecting what confidence level I am at because the more centered I can get my fingerprint. So what they use is a recognition policy through total error recognition. So the total error rate is the number of false acceptance rates and the number of false reject rates. The false acceptance rate is if they were to say, for example, Ria, your fingerprint is my fingerprint. But the false reject rate is, for example, if they were to say, Joyce, your fingerprint is not your fingerprint, which is clearly wrong. And then they take that over the total number of access and they try to find the balance to see whether you have been authenticated for the system. And so what's really hard about current biometric systems is that they can't find the threshold to which this is actually useful. You have a false reject rate, and you have a false acceptance rate, and there's a threshold in between. But now, if you have a false acceptance rate that's too high, then other people can get into your phones or devices. If you have a false reject rate that is too high, on the other hand, then you can't get into your own phones half the time. And that's what we see with Apple sometimes, when you keep pressing and it's not letting you in. And this is where multimodal biometrics comes in. So there are different types of multi-biometrics, and this can be multi-sensor, so using different sensors for one system. It could be multi-algorithm, so using different algorithms to track one thing. It could be multi-different interfaces, so looking at different interfaces and connecting them and making them into one. But the one I'm focusing on specifically is multimodal. So taking the fingerprint sensor, taking the face scanner, taking the iris scanner, putting it into one, and using that one as multiple identification levels. Because the more identification levels that you have, the harder it is to fool each one. And so let's think about our grades for a second. Everyone gets grades. And everyone wants to be in this green range where you're getting A's and you're like, yes, I am living life. My grades are good. I am doing well. Whereas if you're at the F, you're like, well, there's something that needs to be done. And let's say your parents tell you, if you get, let's say, mostly A's on your next report card, you get money. But now what does mostly A's mean? It could mean you get all A minuses, and that's all A's, still A's. A minus is still an A. Or you can get 4 A pluses, but then 4 B minuses, but that still balances out to the A minus range, right? And now here's where fusion comes in. Fusion can happen at different levels in biometrics. There's the sensor level, taking all the raw data. There is the feature level, taking different features and making it into one vector, so one hash map to recognize you. And then there's also the actual detection rate, where it's a score, and there is a Boolean fusion rate. So here are the two different ones that I've just mentioned. So this one is the decision fusion, and this is where it takes each system. So fingerprint, yes. Iris, yes, but face, no. And because you get 2 out of 3, it still lets it go. Whereas there's the score level where it's you got an 80 in this, a 90 in this, and a 90 in this. You add it all up, and you find the average. And if your average is higher than a certain threshold, then you're good. Now, see, this would be an example of having a score-based one. Because here you have A minus, and you have a bunch of A minuses, which is still an A minus. And then you have A pluses, but you also have Bs. But then they still average out to the same, 90%. So that would be you get the money. This, on the other hand, would be with the Boolean decision making. If you get enough A pluses to overthrow the B minuses, then you get it. In this case, there would be some sort of lock system because you have, let's say you have 8 biometric systems and 4 of them are A pluses but 4 are B minuses. Now you wouldn't be able to use it because there's a certain gap between them. And so now this is why people are using the score-based system more, because it's more accurate, or there's a smaller threshold for you to get into this situation. And looking at companies that are working on this right now, I see 2 Japanese companies, 1 Korean company. We see 2 American companies, but one of them doesn't really focus on biometrics. The other one, believe it or not, was just acquired by 3M for $943 million. But still, we've never heard of it. Why? You know, there's so many applications to this, and there's so many things to do with biometrics, but no one is actually doing anything with it. And I was so fascinated by this company, but that they're the reason why I want to start biometrics to begin with. Hyper actually uses biometrics for blockchain. And what they do is take decentralized authentication and use it for blockchain access. So that means taking your fingerprint and storing it on your phone. There's no central application or no central thing that's storing all of your information. It's just your phone. And so you're able to just access everything from your phone, all of your information. And it takes this decentralized application to make sure that no one is able to store all of your information into a database. And now they're also working with multi-biometrics, where they want you to be able to take all of these different sensors and all these different technologies and put it into one to make it super secure. Now, I asked you at the beginning to tell me what you thought of this image. Chances are, if you go to the person next to you, they wouldn't have thought of the same thing as you. Or even if they did, they might probably have thought of that thing in a different fashion than you. So someone might be super happy about the desert. Some people might be super sad about the desert. And now it gets even more complicated because I asked you to find a connection. If I ask you to find the connection, there's there's literally zero chance for you to be able to find the same sort of connection with the same sort of feeling. Even if there was a small chance, it would be 0.00001%, which is definitely more secure than the 10,000 combinations that a 4-number security system has. And this is what I would like to end with. Visual evoked potential. This is what the next step of biometrics is. Being able to take EEGs, taking different parts of your occipital cortex, and looking at how it responds to light stimulus. Everyone responds to this light stimulus differently, and if we're able to authenticate different things like blockchain using this, then imagine all of the possibilities that we could do with security, with airport security, with banking security, all of this. Not to mention the fact that it could also work with blind people. Now, what we can see is that a lot of the occipital cortex response is from macular projections, meaning that it's light. So it would look at the levels of light regardless of whether you were able to see different projections or not. And so this is the future of security. We're so busy being held back by movies and what they show us about people being hacked in movies that we're not ready to move forward. The Japanese are moving forward, so why can't we move forward? Stay tuned for more about visual evoked potential.